We are going to write quadratic equations in vertex form. Okay, what does that look like? Y equals a times x minus our h squared plus our k. So could we convert to standard form after we have it in vertex form? Yes, but we're not going to be asking you to do that specifically today. Okay, so we're going to start out with these word problems that we already know how to draw pictures for. We already did this on the very first day, and we've been practicing it ever since. Coach Minges is kicking a soccer ball. The ball reaches a maximum height of 20 feet after flying a horizontal distance of 12 feet. Write a quadratic function in vertex form to model the flight path, assuming that the ball is kicked at 0, 2. So is the ball on the ground when she kicks it?
Yeah.
No. Okay, so she's like kicking it in the air. Okay, is that possible, soccer people? Okay, just making sure I didn't, make something up. All right, so we know that a parabola this is going to be the flight path-ish, right? Now, we could put our axes anywhere we want, right? Where would be a really good place to put the axes?
At the bottom of the parabola and on the side of it.
Yeah, so I want to make it so that my 0, 2 is on the y-axis. Okay?
You gotta make the
It's going to be a little bit higher. Does that make sense?
Yeah.
Okay, so let's start labeling our stuff. We know that it's hit or kicked from 0, 2. Okay. We know that it's going to reach a maximum height of 20 feet. So the 20 feet is the up, is the y value. Okay. Okay, how far does it have to travel horizontally? 12. So this distance is 12. All right, so I want you to see if you can give me the vertex. Be very careful. This is also feet. Okay, what's the vertex? 1220 is correct. Okay, so we know a whole bunch of stuff. If I think about vertex form, let me rewrite it here. Y equals my A times X minus H quantity squared plus K. We know a whole bunch of this stuff. Do we know the H?
Yes.
What is it?
It is
It's 12. Okay, it's going to look like negative 12 when we plug it in. All right, what about the K? 20. Okay, do we have another X and Y value that we can plug in? Yeah, what are they? 2 is the what? It's not the K. No, we already have the H and K. This is just another, okay, this is the H, this is the K. This is just another point on the parabola, right? So this is the X value and this is the Y value. So I can put in the 2 for the Y.
That's the minus
Yeah.
which is
And then I'm going to put in the 0 for the X. What is the only thing that I don't know? A. So could I put in all of the stuff that I know and then solve for that A value that I don't know? Yep, that's what we're going to do. Okay? So this is the tricky part of today. Okay? This is going to require your thinking cap and that you're being very careful. Okay, so I'm plugging in my 2 for the Y. I don't know the A, so I'm just going to leave that as A. Okay. What is 0 minus 12 squared? Well, it's negative 12, right? What's negative 12 squared?
24.
Square it. What's 12 squared?
144.
144. So do you see that we're multiplying a with 144? Because we're doing 0 minus 12 squaring it, 144. Whether it's positive 12 or negative 12, we don't really care, because when we square it, it's non-negative. Okay, and then the plus 20 at the end. Everybody okay with that step? Okay. So, the next thing I'm going to undo is subtracting 20 from both sides. Right? I got to get rid of the plus 20. So I'm going to subtract 20, subtract 20, negative 18. Why is that negative going to be very important?
Because it's down like a frown. So
Down like a frown. So I know that my a value must be negative. Okay, so if you are doing this and you get an a value that's not negative, you better go back and check your signs in your work. Okay, how do I undo multiplying by 144? Division. Divide both sides by 144. Good. Okay, this is the part where you might need a calculator for it, but we're going to try without a calculator. True or false? 18 and 144 are both even.
True.
Okay, can I divide away a 2?
Yeah.
Okay, what would that be? What would I get? I'm getting 57. No. I'm getting 77. Is that right? No. Is it 72?
Yes.
Oh my gosh. Okay, so I'm getting negative 9 over 72. Well, that's a little bit easier. Why are you saying 8? How many times does 9 go into 72? 8. Okay, so where do I put the 8? On the bottom or the top? On the bottom, because that's where the big number is. Okay, so if my first numbers are kind of big, yuck, okay, can I start dividing away little numbers that I know evenly divide these until I can reduce something I recognize? Okay, that is a very powerful strategy when they take away your calculator. Okay, so this ends up being our a value. Our a is negative 1 over 8, negative 1/8. So we now have a. We know what h and k are. Can you write me an equation in vertex form? Okay, go ahead. See if you can do it. Person next to you. Okay, how did you do? Okay, so we're going to use vertex form twice. The first time we use it, we have to plug in everything we know, and then we solve for the a value. At the end when we use it, do we plug in the x and y, or do we just leave those be variables? We let them be variables so that they give us the curve, the input-output curve. Okay? We want those to vary. All right, that's it. That's how we do it. That's the end. So kind of easy, kind of hard. Whoops, I forgot part B. All right, what does the point, what is the y-intercept?
0,
0, 2. Okay, so the first directions say state the y-intercept. So we just have to write it, 0, 2. Okay, now we have to explain what it represents for the scenario.
The initial point. The initial point.
Yeah, so it's like the starting height and horizontal position for the flight path, right? It's just where the flight path starts. So the starting I'm sorry, I messed up. I didn't really do it like wrong, but it's not specific like the way we've been practicing. So we need to explain what the numbers are. So okay, so we're going to say, we can say the initial height of the ball is 2 feet. Does that sound better? That's better. Initial height of the ball is 2 feet. Okay, whenever we use the word initial, okay, that's telling us that the x is 0. That's code for x is 0. Any questions about that? All right, let's try another one. All right, this time we've got Coach Vogler bumping a volleyball. Okay, so Coach Munges was kicking the volleyball, impacted the volleyball, was like 2 feet. Now bump might be a little bit higher, especially for Coach Vogler because she's kind of tall. So we're saying that she's bumping it at 0.3. Does that make sense to everybody?
Mm-hmm.
Okay, she's got to get under it, but it's a little bit higher than a kick. So we're going to draw our picture. Ball goes up, ball comes back down. Okay, what is the maximum height of the ball? 19 feet. How far does the ball travel horizontally to reach that maximum height? 8 feet. Okay, go ahead and write the vertex. Okay, I like to label my H, my K, and my X and Y so that I substitute everything in the correct spot. So I'm labeling my 8 as my H, my 19 is my K, and then my 0 and my 3 are just the X and Y on the parabola. I just need any X and Y, and they gave me those. I'm going to plug in everything I know, substitute it all into vertex form. Okay, so what is the y that they gave me? 3. Do I know the a value? No, so I just leave it a. What's the x they gave me? 0. What's the h? 8. And the k?
19.
I'm just plugging in, substituting in everything that I know. The only thing I don't know is the a value, and that I can solve for now that I have everything else substituted in. All right, so I can kind of do 2 things in my first step. I can subtract away the 19, and I can square the negative 8. 0 minus 8 is negative 8, right? So what's negative 8 or even positive 8 squared? Yeah. So I have an a times the 64. I'm subtracting away the 19 on both sides. So the 3 is positive. It's the 19 that's negative, right? Just be careful when you write it on the other side. You have a negative 16. Okay, that's good because we need our a value to be negative. Otherwise, this parabola will open up and it will not describe the physical phenomenon that we experience on this earth. Okay, what do I divide by? 64. Okay, so pretend you don't have a calculator. What common factors do you know that 16 and 64 have? 8. So what if we divide away an 8?
Negative 2 and 3.
Yeah. Can I reduce that again?
Yes, 2
Oh, yeah.
negative 1.
It's still divisible by 2, so I can divide away 2 from the 2 and the 8, and I get negative 1/4. Yeah. Okay, now I'm going to write my functions. I know my a value, I know my h and my k, so I know that it's going to be something like f of x equals negative 1/4 times x minus h. Whoops, what's my h? H is 8. 8 squared plus 19. Does it matter if I use f of x or y? No, because I'm writing a function. So in function land, those two things are the same. Outside of function land, they are different because f of x promises us we have a function, but y does not. On the first one, we did y. I'm just showing you that you can write it either way, that they're both correct. All right, go ahead and state the y-intercept and what it represents for this situation. Oh my gosh, I cannot. Show. Right. Okay, can we just really quick before we flip go over some of the transformations in these graphs? So what does the negative a value do to my function? Okay, reflects it over the x-axis. Okay, what does the 1/4 do? Close? Yeah, it's a vertical compression by 1/4. Okay, what about the 8? Shifted right 8 units. Okay, what about the plus 19? Yeah, shifts up 19. Is it enough to just say up 19 or do you have to say shifts? Okay, you gotta say shifts. Okay. You can probably imagine that when you're hitting a volleyball, sometimes it might go straight up in the air almost and be like really steep. Other times it makes like a huge arc. Okay, so that's been vertically compressed quite a bit. You know what I'm saying? It just depends on the angle that it gets bumped at. Or, yeah. All right, what about this? I have a diver that jumps from a platform 10 feet above the water. The diver reaches a maximum height of 11 feet at a horizontal distance of 2 feet from the edge of the platform. Okay, so I'm going to draw a picture. Okay, what is the starting height of the diver? 10 feet. Okay. They don't get much higher. I think they're probably diving mostly forward and not like up very much, but they're just going like a little bit higher and then they're coming down into the water. So what I want to draw your attention to is that part of this graph is like over here and we don't even care about it, right? Okay, which is true on the other two, but it's much more obvious on this one. All right, how far did they travel horizontally to get to the maximum height? 2. What is the maximum height? 11. Okay. So my H is 2. My K is 11. What are my X and Y? 0 and 10. Oops, oops, oops. Sorry, we are experiencing technical difficulties this time. Okay, I'm going to substitute in everything I know so I can solve for the one thing I do not know. Okay, my Y value is 10, my X is 0, my H is 2, my K is 11. Okay, 0 minus 2 is negative 2. If I square that, I get 4. So I have 10 equals A times a 4 plus 11. How do I get rid of that plus 11? I subtract it away. So it's going to be negative on this side, and it's going to be negative on this side. What sign is the 10? It's positive. So I've got positive 10 minus 11 gives me a negative 1. And then I have A times 4. Oh, this one is nice. We don't even have to reduce. You like this one? This one's my favorite. All right, so I'm getting negative 1/4 again. Okay, go ahead and write your equation. Okay, someone tell me what the y-intercept is and what it represents for the scenario. Yep. Okay, so the state the y-intercept is 0, 10. And what it represents is the initial height of the diver in feet was 10. I used to get really hung up on this kind of stuff when I was a kid because I'd be like, but their like head might be in a different height than their body. So what you can assume on these is that they're just talking about the center of mass. Does that help everybody out? Okay. You can just assume we're talking about the center of mass. Okay, do we need to do one more? All right, we'll save this for a warm-up for another day. Yeah, go ahead and work on your assignment. Okay, we got a frog jumping from the bank into a pond. He's going to reach a maximum of 14 inches after going a horizontal distance of 12 inches. I'm going to draw my picture. We know that the bank is 2 inches above the surface of the pond. So here's my bank. That's the height that he's starting from. And then he's jumping to a maximum of 14 inches high after going 12 inches horizontally. So I know that my vertex, whoops, I kind of didn't do that very good. Okay. Wow, that's really going to bug me. Okay, it's worse. It's worse. We're just going to ignore it. It is 12 to the right and then 14 up. Okay, so my H is 12, my K is 14, my X is 0, and my other Y is 2. I'm going to substitute everything I know into my vertex form and solve for A. Okay, I know that my Y is 2. I don't know my A value. My X is 0. My H is 12. My K is 14. All right, if I subtract away 14 from both sides, the 2 is positive. I get a negative 12. And these go away. If I square 0 minus 12 is negative 12. If I square negative 12, I get 144. So my A is getting multiplied with 144. I can divide both sides by 144. Yeah, I know that 12 goes into 144 12 times, so I'm getting negative 1 over 12 for my A value. Okay, now I know my A, I know my H and my K, and I can write a quadratic function in vertex form. So my function will be y equals negative 1 over 12 times x minus 12 squared plus 14. Now I have to do my y-intercept and what it represents for this scenario. So my y-intercept is right here, 0, 2, and it is the initial height of the frog is 2 inches. That's the height from which his jump starts. Whenever I say initial, that's code for, hey, my X or whatever is 0. Okay?